Dear participants, in this video, we will understand how to calculate cumulative probability for two different data points or two different points for a normally distributed curve. In this example, we will understand a specific case study where we have historically 200 participants who have enrolled for Lean Six Sigma Green Belt certificate, and they have taken certain hours to get certified. So some of them take 30 hours, some of them take 40 hours, some of them take 50 hours. So in the past, 200 people have enrolled for Lean Six Sigma Green Belt certification, and they have taken certain time to get themselves certified. So how much time they have taken, how many hours of training they have attended before certification, that information is available for 200 participants. Now the question in front of us is, this data is normally distributed with an average of 40 and with a standard deviation of 8 hours. It's not 8 days, sorry. Average of 40 and with a standard deviation of 8 hours. Now the question that our client asks is, if I enroll a set of participants from my organization, what is the probability of these participants getting certified within 34 to 48 days? So this is your historical data. Considering this historical data, which is normally distributed with an average of 40 and standard deviation of 8 hours, what is the chances of my team getting certified within 34 to 48 days? 48 hours. That is the question in front of us. So what do we know here? My historical data is normally distributed with a mean of 40 with a standard deviation of 8 hours, and a new set of people who are going to onboard for this program. What is the chances of they getting certified within 34 to 48 hours? Now, to give you a visual understanding of what is this case study all about, let me copy this data, take it to Minitab, and try to draw a histogram out of this historical data. Now, this data is normally distributed. So I go to graph, I select histogram, and I select histogram with a fitted line, and I select this hours to certify as a data. I go to scale. In reference line, I wanted to have reference line at 34, 40, and 48. Why 34? Because the team who are going to enroll now wanted to know what is the chances of they getting certified between 34 to 48 days. So 34 is the minimum duration within which, or the time frame by which they want to get certified. 40 is my average, and 48 is the maximum days by which they want to certify. So I'm going to have a reference line drawn at 34, 40, and 48. Now I click OK, and I click OK. I get a graph which looks like this. So let me take this graph to the Excel file that we were here, and let me paste that graph here. Now, what is the question in front of us? The question in front of us is, what are the chances of my team getting certified within 34 to 48 days? So mean is here, average is 40, standard deviation is 8. So if the question would have been 32 to 48, I could have directly told 66.8, because as per the normal distribution curve, average plus 1 standard deviation of 48, average minus 1 standard deviation of 32, we would have had 68.3% of data covered, 68.3. But in this case, it is 34 and 48. So let's see what is the cumulative probability. So to give you an understanding what we are trying to calculate here, is the total area of curve from this point to this point will be cumulative probability of people getting certified between the minimum number of days to 34 days. So this area of curve will be the cumulative probability of 34 days. So let me call it A. So A is the cumulative probability of people getting certified between minimum days to 34 days. And similarly, B is the cumulative probability of people getting certified between minimum days to 48 days, because I'm trying to cover the area under the curve from this point to this point. So B will be the probability of people trying to get certified from minimum days to 48 days. So let me call this as B. Then what I am concerned about in this scenario, what I am concerned about is, I wanted to know what is C. Why I wanted to know what is C? Because if I calculate the cumulative probability of B, and then if I calculate the cumulative probability of A, then if I subtract the cumulative probability of A from B, I will get C. Because this is what I wanted to really calculate, right? I wanted to really calculate the cumulative probability of people getting certified anywhere between 34 to 48 days. So if I want to know that, I need to calculate the cumulative probability of people getting certified from minimum days to 48 days. Then I need to calculate people getting certified from minimum days to 34 days. So that is the second thing. And once I do these two, then finally I'll be able to understand what is the chances of people getting certified anywhere from 34 to 48 days. So this area I'll be able to calculate, provided I know this area, and then subtract A from B, I'll be able to get C. So that is a question in front of me. How do we do this? There are different ways of doing it, but I'm going to teach you the very easiest way in Excel, where if you type is equal to, so before that we will enter few values here. So mean 40, standard deviation 8, and we want to know the cumulative probability. So I'm going to use the word CP, cumulative probability or cumulative probability for 34, cumulative probability for 48, and then the difference between these two is what we really want. So how am I going to calculate this? I can type is equal to NOR. If you see here, it shows normal distribution, right? NORMDIST. So I select this. So it says, what is your X? X is nothing but the point for which we wanted to calculate cumulative probability. In this case, it will be 34. So I select 34. Next, I need to give my average. Next, I need to give my standard deviation. And finally, I can either enter a value 0 or 1. If I enter 0, it will give me absolute probability. What is absolute probability? The chances of people getting certified exactly at 34 days. It's not from minimum days to 34 days, exactly at 34 days. That's not what I want. I want people who will get certified anywhere from minimum number of days to 34 days. So I have to enter 1 here. If I enter 0, it gives me the absolute probability. If I enter 1, it gives me cumulative probability. So what is the cumulative probability? If somebody want to do a Lean Six Sigma Green Belt certification program, if they want to complete their certification within 34 days, the chances is 0.22. That is the cumulative probability, anywhere between minimum number of days to 34. And similarly, if I repeat the same formula for my 48, because that is the other point in the curve. So let me copy paste the same formula. Only thing is X will be not 34, but 48. So this becomes my cumulative probability of getting certified within 0, or that is minimum to 48 days. So now I found out the value of A, which is 0.22. I found out the value of B, which is 0.84. Now I want to really find out what is the cumulative probability of people getting certified anywhere between 34 to 48 days. And the answer to this question will be probability of minimum number of days to 48 minus cumulative probability of minimum number of days to 34. So the chances of people certifying anywhere between 34 to 48 days will be 0.61. So this is the answer to this case study. I hope this was useful, how to calculate cumulative probability using Excel. I'll also explain in my upcoming video how to do the same cumulative probability calculation in Minitab. Thank you, friends. Thanks for your time. So I'll give you the description of the other video, how to calculate cumulative probability for normal distribution in Minitab. I'll give you the link of that video in the description of this video. Thanks for your time. See you in another Lean Six Sigma quality or Minitab related video. Thank you.